All right. So there'll probably be a few more people that'll kind of straggle in here as we carry on. So you're seeing. I hope everybody is seeing my the two little SRS robot guys there. The one laying down on his side. Yeah. Okay. I'm using the gallery view here, so I'm just seeing all of your faces on the one screen, and then I'm seeing that on the other screen. We'll make sure everybody's seeing what I'm seeing. Okay, well, welcome everybody to the November meeting of the Seattle Robotics Society, November 2025. One more month after this, and 2025 will be history. So glad that you guys could be here. And if in case you hear some background, a couple of my grandnephews spent the night with us, so they're playing connects right now, but they're shooting arrows all over the house. So if you see something fly behind me, don't be alarmed. It's probably just a connects arrow. So all right. So this is the general agenda that we'll follow. This is pretty much standard. It's kind of a boilerplate that I use, and it's not hard and fast, but we will generally speaking follow this. And kind of the main things to note are the round the room, whenever everybody will have a chance to share, whatever they have, and I'm hoping there's plenty. I'm seeing at least one there. It looks like Craig Austin's got a cool little robot he's going to share about, so I'm looking forward to hearing about that. But anything that anybody has that they want to contribute. And so that'll come kind of after this beginning part of the meeting. So probably roughly 10:30-ish or so, we'll get to that. And then we'll do a short break before we start our presentation, round 11. So if your microphone happens to be on, oh, Bob, go ahead and mute your microphone. If it happens to be on and you're not actively speaking, just please mute. I think I actually have that capability, and I can also ask you guys to unmute too if necessary. But yeah, so and the chat. So open up your chat window off to the side there, so you can contribute as well as see what other people are contributing. So if anybody has anything interesting, links, any kind of information, go ahead and throw it in over there. And let's see, our Robothon, our SRS Robothon merch store. It looks like it's maybe I'll have Lloyd just jump in a little bit, and I don't know if do we have any new graphics available there for
yeah, so not anything super new, although Steve, that one t-shirt image that you sent me, I did process that and put it up.
Mhm.
So if somebody wants
Cool.
that one,
that was the one from '99?
Yeah.
That really pretty colorful one? Yeah, that's
Yeah,
when
and
I would wear that t-shirt to meetings, and people would walk up to me and go, "Where can I get one of those?" And it's like, sorry.
so it's up
One of a
there,
kind.
but I will note that the cleaning up the imagery, because it was taken from a photo, I believe is what you did.
Yeah, yeah.
It did okay, but it's going to have a worn look to it. And I
Well,
just, after trying to clean it up, I decided that's probably better. So let's leave it like that.
It's a good fit for a t-shirt, right?
Exactly. Yeah. So if anybody wants to, you can just go to the site. The QR code there will just take you right to it, as will the URL. We've got t-shirts, mugs, phone cases, bags, hats, and notebooks, all kinds of stuff. If somebody wants something and you don't see it, let me know. There's a lot of stuff that in the background that I could turn on if somebody really wants it. I thought, things like SRS throw pillows and shower curtains, I thought might be a little overkill in this case, so I haven't turned those on. But, if you really want an SRS shower curtain, you can do that. Yeah. It's actually really easy for us to, to set that type of stuff up. Also, if somebody has a particular like Robothon image or something, we're open to, send it over, and as long as it's good quality and reasonable, we can put that in.
So could they do like color photograph type of imagery then?
Somewhat. If you look, I haven't explored just because most of our imagery came from t-shirts, right?
Hmm.
Where the printing process for a t-shirt is dependent on the number of colors, right? The more colors, the more you pay. And they can do full color, but it's
Okay.
literally 3 times as much because you're 3 printing passes, right? You're printing
Okay.
a.
Yeah.
I haven't explored with Redbubble how that works with them. I
Okay.
think it's actually an inkjet printing process or a dye sublimation process they use on the back end.
Okay.
So I suspect we can actually get more colors and not run the price up.
Oh. Hmm.
But I have not explored that yet.
Okay. All right. Well, that sounds, yeah. Well, I know the mug on there is,
Yeah.
it's two. I mean, you got the black
And
outline around
yep.
the yeah, and then the yellow. And but
Yeah.
that T-shirt that you're talking about, that thing was like that was full color.
Yeah.
As I recall, they were kind of pricey at that time just to get made because of that. So
Hmm.
yeah, but
Yeah. In the later years, we kept all of our t-shirts, monochromatic just to keep the price down.
keep the price down.
Um,
Yeah, yeah, no, okay. All right. So anyway, yeah. So you can hit that QR code on there, or and you can also get to this from the SRS website too. Of course, right on the front page there. There's a link to the merch store. So anyway, check that out just to see what kinds of things are available. I don't see. Yeah, we don't have Donna Smith here today to kind of talk a little bit about her Build It with Arduino um, sessions. So usually she does these. I think they're typically the last Saturday of the month. So sometimes they're the next week after this meeting, sometimes 2 weeks after this meeting, depending on when this falls. Um, so I didn't know for sure. I just got either the 22nd or the 29th there. So it's going to be one of those two, I'm guessing. And then she does this from 1 to 3 Pacific time in the afternoon. And she and the folks that have been participating have been building Arduino based competition robots. So, um, but you can go to you can go to Meetup, and then you can look for the Build It with Arduino Meetup group, and she posts information there. And I think she's got you can get to videos of past meetings and things like that. So just to keep that in mind. Let's see, and Robothon. Well, I'll let Lloyd, since he's our Robothon guy here. I'll let you speak to anything that you might want to bring to people's attention.
okay. So basically, October 4th, we had our fall event at Robothon or at sunnycrest.org. Not hold it, stop.
Crest
Bunch of
Elementary.
URLs.
Yeah.
October 4th, we had our event at Sunnycrest Elementary School. And I actually wasn't able to attend this year. I had a issue going on. So again, thanks to Donna and John and everybody else for kind of covering for me. But from what I heard, it went really well. We had a reasonable attendance. There was some good bots out there, and everybody had fun. We are currently planning out what we're going to do next year. Um, we're looking at possibly changing up. So in the last few years, we've kind of gotten into this cadence of doing an event in the spring at the field house and an event at the fall at Sunnycrest. And we're looking to maybe change that up. No, no, we may do the same thing. We may not. We're going to discuss it in our December meeting. If anybody has any preference as to what you would like to see, let us know. We're also talking about maybe trying to do a joint event with the war group again. So we're going to get they're going to attend our little meeting there and see if there's something we can line up with them. We're going to also kind of be looking at what can we do to get folks more folks involved. For we need some new blood. It's kind of been the same people every couple of years, so we're going to be looking at that too. If anybody has any thoughts or ideas on, um, you know, what would be good to get more people involved, or what would you like to see to get more involved, reach out to myself and, you know, basically let us know. So probably December or January, we'll have some plans we can announce for next year.
Okay. Excuse me just a second. Okay. All right. Thank you, Lloyd. Get back to that one. Okay. Yeah. So, if you're curious at all about, about the Robothon, and the robothon.org website has historical information, so you can see things that have happened in the past, and it's always lots of cool, fun stuff. So check that out if you have the opportunity. Just to mention here on the SRS website, I've got some links to some resources, maker spaces, and there's a resource page where I collect links. Sometimes people will send me links. I'm going to put one up there pretty quick here about it's a women's engineering, what would you call it? It's like women's engineering resource page. It's actually a pretty cool. I was looking through this thing going, wow, that's neat. So I'm going to add that there. And while I'm thinking about it too, I got an email from a gal about electrical, or excuse me, yeah, an electrician training that is happening. They're free evening weekend classes starting in January that happen at the Puget Sound Electrical JATC Training Center in Renton. And so there's coursework, tools, work gear for free, support services, interview preparation. Graduates are interviewed for limited energy or low voltage union apprenticeship program. And then the top performers can earn a direct entry into a union residential electrical apprenticeship. So if anybody knows somebody who would like to get into doing electrical wiring, possibly, whether it's commercial, could be residential, but I know electricians are very well paid as they work their way up the chain. So it's a great way to make a living and get well paid for it. So I'll post a link to that, but you can also email me at the SRS email, Seattle Robotics Society at gmail.com, and I can forward this email to you. So if you or somebody you know might be interested in that, put that out there.
I'd just like to add that the electricians are one of those jobs that are not likely to be replaced by robots in the next few years.
That is very true. Yes, there's a lot of things that robots may very well do, but there's an awful lot of things that they will probably never do very well. At least not for our lifetimes. So, yeah, let's see. Soliciting presenters. I'm always interested in possible presenters. So if you come across somebody that you think would be a good fit for our group, please let me know. And do keep in mind, if Eastern European is and like Asia is a little bit tricky because of the time zone differences. There's a substantial time zone difference that might require us shifting a meeting if we were to try to get somebody from there. We had a fellow from Japan that we had to shift to a mid-afternoon meeting here at Pacific time in order to be able to not have him get up in the middle of the night to do a presentation to us. So, but most places actually are within a reasonable time. So we are anywhere within the United States, Hawaii, and Western Europe, everything's no problem. So, but if you do find somebody, feel free to chat with them a little bit about what we do and what we're interested in, and you can pretty much anything except making specific arrangements. Just have them either reach out to me or pass me along contact information, and I'll reach out to them. So always lots of possibilities. We have I have these kind of in my hip pocket in case a presenter can't show up at the last minute. So we usually have an option to go to fall back on a open discussion. So these are some of the topics that we've considered. So I've got kind of, like I say, I've got hip pocket presentations that for discussion starters. So I'm not an expert on any of these topics, but it's always fun to just sort of throw questions out to the group and chat about this stuff. And we usually always have a good time when we do that. So, whoops, a little bit. Okay. So coming up, I'm seeing I misspelled your name there. Sorry, Jason. I didn't. I'll fix that. I hate it when I do that. I try to be consistent, but I'll get that. I'll fix that before on the official posted information. And is it how do you say your last name?
Just like it looks, Seawall, Seawall.
Seawall. Okay. Thank you. Yeah. So Jason Seawall is going to be presenting to us on what I was looking at your website and it's like, wow, that looks like super cool. I know you joined us, or did you join us, or was it?
Yeah,
you did join us for a meeting
a couple of months.
Yeah, a couple of months ago. Yeah, and you kind of gave us a little bit of a teaser of what you got here, and we said, okay, yeah, we got to hear more about that. So we're looking forward to your sharing how that works.
Yeah.
And Bob Higgins is online here, and he's going to be talking some more about computer vision. So you're welcome, James. James Newton has been and he's been every meeting he's been mentioning that.
I guess this is the mention this meeting then, right? I don't have to bring it up again because you already did.
Yeah, that's right. Yes. So,
hey Steve, just a quick double check. Yeah. We were talking about the choosing the right programming language for February 21st.
For February, yeah, and thank you. I just noticed that I forgot to put you in there. So Lloyd Moore is going to be talking about the presentation that was supposed to happen last month and didn't due to Zoom technical difficulties. Is going to happen in February, and I'm sorry I don't have it on there, but it will be there. Yeah. So I post this slideshow along with our the rest of the information from the meetings, and I usually have to go back and make changes and corrections and fix things and all that. So I'll make sure that that's all in there. Okay. I was thinking Craig Austin. Wow, that sounds really familiar to me. And now I'm thinking, okay. And you can probably, if you're looking at the gallery view, you can probably see he's got a picture of his machine there. So Craig is going to be talking to us in detail about that, probably coming in January. But looks like we'll get a little bit of a teaser for what's coming. So. Yeah. So, okay. So February is also no longer an open slot. So the first open slot we have next year is March, and third Saturdays from March on. So I will be working on filling those up here in the next coming months. And as always, you can go on the front page of the SRS website, and that's where our meeting links and stuff are there. They do not change from month to month unless something weird happens with Zoom and I have to recreate one like I did this time. But that will always have the latest Zoom link available for you, and you can access past meeting information. And we've been recording these meetings since mid 21. I think. So we have we're actually getting quite a history now of past meetings that you can go and revisit. And if you do have any other feedback or anything for me, you can just hit me at the SRS website, SRS me email there, and I'll be happy to respond to that whenever I get around to reading the email. I don't hit that every day, but I try to hit it pretty regularly. Okay, and coming up a little later. Yeah, I did it on the. Oh, I tell you, I got you. I'm sorry about you getting your name misspelled there. That's just. I'll probably fix that while when I take the break here. I'll get in because I got to get in there. That's just going to bug me if I don't do that. So anyway, we're going to be hearing a little bit more about NEPi, and you'll learn later what that is, and this hardware software development and integration that Jason's company does. So looking forward to this. This should be really cool. Okay, so we now have you guys all have the opportunity to just show off whatever stuff you've been working on, little gadgets and things that you would like to share, or if you have projects you've been working on. So I know I think James has got something, and okay, all right, go ahead, James.
I'm so excited about this. This is a really cool little project. So I don't know if can you click on the link that I shared, Stephen, or is it?
Yeah, I can. Yeah.
Awesome.
Let me.
So what this is this is my friend Hong Yang, who is a former coworker of mine back in the Haddington Dynamics days, and he has come up with this thing called a leader arm, which I don't know if anybody works with robotic arms much, but a leader arm is basically a robotic arm that doesn't have any motors in it. So what it's doing is it's just got the encoders in the robotic arm, and then you move the leader arm around, and then it sends the data to the actual. There we all are.
Yeah, sorry about that. It'll take me a sec here to get to the right screen. So
is it easier if I share it or no?
I think I'm most of the way there. So just give me just be
sorry
patient
about that.
No,
but I wanted you guys to see this because it's really, really cool. Okay. So the point of having leader arms, like why do you want to have a leader arm to move the actual industrial robotic arm? And the reason is because you can't move the leader arm in the same way that like the robotic arm can't move, right? So that means that you can't like get the robotic arm into like points of singularity or areas where there's like multiple different ways of getting into a particular pose. If you've worked with robotic arms, you know this is a real serious thing. That there's points where there's multiple different ways to get to a particular location, or you run up against limits or things like that. And the leader arm is limited in terms of what it can actually do. I don't know if you can play that video, but
let me try it.
What it then allows you to do is nice with sound.
Introducing discrete mechatronics premier leader arm, the DeltaTrack. Compact, precise, and effortless to use. It is designed to put motion capture and robot control directly in your hands. This 6-axis passive arm features high-resolution angular encoders at every joint, delivering accuracy down to 0.3 degrees. At just over 30 centimeters tall, it is lightweight, ergonomic, and built to move as naturally as you do. DeltaTrack provides real-time motion feedback at 120 frames per second, and it runs on less than 250 milliamps of power. Guide a robot directly, capture precise motion for engineering, or train machine learning models with clean, high-quality data. The DeltaTrack prototype has already undergone extensive real-world beta testing for motion control and dataset collection by a partner company. We utilize a high-precision carbon fiber additive manufacturing process, which promises a lightweight and durable product. Our encoders are custom-made and manufactured in the United States. Discrete Mechatronics DeltaTrack is performance engineering made simple, a powerful and precise tool for makers, educators, researchers, and developing physical AI infrastructure.
So the point is that that's 3D printed, but the real magical part of it is actually the encoders, which he developed based on his own ideas and technology. And what's really exciting about the encoder is it's an array of Hall effect sensors. It's not a Hall effect array. So what that means is you could see in that one screenshot there of the board going together, it has a hole in the middle, and that's a pass through for the joint. So instead of like if you use a Hall effect array chip, you have a magnet that's rotating over the top of an encoder, or if you use like an optical encoder or something like that, you have a shaft. You can't put things through the shaft of the robot at the joint because the shaft of the encoder is in the way. And this thing just has this open hole. And what it's doing is there's a ring magnet that runs around underneath those sensors. So it's an array of Hall effect sensors, not a Hall effect array. And as that ring magnet rotates, the sensors tell you what angle the array, the magnetic field is at. And so you can pass wires, you can pass air, you can pass whatever you want through the center of the encoder, which is why the leader arm doesn't have any wires on the outside of it. You know, they all run up through the middle. And the because it's an array of sensors, it's doing basically differential sensing. So it isn't susceptible to noise or the interference of the Earth's magnetic field or anything like that. A lot of these Hall effect arrays, they have really good precision, but their accuracy is pretty bad, and they don't reject noise very well. So, they'll advertise that you can getting like 19, 20 bits of, data out of them. But when you look at it in a real world setting, you're getting maybe 10 bits of data out of it because there's so much noise, and the alignment of the shaft has to be perfectly precise. Whereas with this, it doesn't. Again, differential signaling. So that if the Kickstarter funds, then he's going to release that encoder for sale and then eventually open source it. It's running on a Raspberry Pi, each one of those little joints. So the joints themselves are like $20, $30. They'll probably sell for around 100, just based on, the fact that they're non-contact and through hole and all that kind of good stuff. Let's see, what have I missed? Oh yeah, really high accuracy. It's currently at 0.03. That's including the noise. So with a little bit of filtering, you can get down to like 0.003 precision and 0.03 accuracy. Anyway, I love the guy. He's great. Former coworker, really wonderful person. And I really hope that people will share that around with anybody who's like in research or industry, who might be teleoping robots or working with collecting training data, or just, running an arm to train it on a particular path and then play that path back. So thank you for taking the time, and I hope you guys will share it around.
Yeah.
Appreciate it.
So,
Right,
so
right.
James, that's configurable, so he can create multiple variations of robotic arms with different degrees of freedom and segments, etc.
Yeah. So what he did was he did a survey of all the different robotic arms that are out there, and basically the Kickstarter version that you get is based on like the average robotic arm. Like most robotic arms have more or less the same configuration, more or less the same limits in terms of like how far they can move before they run into, the arm runs into itself or things like that. But you'll notice that it's 3D printed, right? So all you have to do if you want a different one is, either you or you can hire him to CAD up a new version of the arm, and you just take it apart, take out the encoders, CAD up the new arm, put the encoders back in again. And because the thing is doing the differential detection, it doesn't have to be mechanically super precise, right? You can just, build whatever kind of a mechanical contraption that you want, put the encoders on there, and you'll get, pretty good setup. So anyway, yeah, let me know if you have any other questions, or if there's anything else. Don't hesitate to reach out or ask questions on the thing. Yeah, anything else on that, or no? I also went to SuperCon in Pasadena, and I thought I would share a few photos and a video. There is a really cool robot at the end of that set of photos, and a soldering challenge, which Hong Yang actually entered and did pretty well in. So if you guys want to take a look at that, you'll see some of the crazy people that attended that, the badge that they gave out, which is a Mesh-tastic RF radio badge, and then the hand soldering of an 01005 component. Just to be clear, you guys probably know if you get down to an 0201, that's basically like the size of a grain of sand. They went to half that size, so 01005, and a guy actually managed to hand solder that with a standard, not with a heat gun, not with a stencil, not with solder paste, with an actual hand soldering iron. Managed to solder that down and get it to light up on the little badge, which, I mean, it just blew everybody away that they actually managed that.
You have a video of that?
Huh?
Do you have a video of that, or just pictures, or a?
I have one video, but it's their reactions. I filmed their reactions when they turn over the board and see the size of the smallest component on it. And I didn't want to share that because there's rather a lot of cursing.
Oh, okay.
And the other thing is, we didn't video it because usually they give them like 40 minutes to solder all the components on there. Had I known, this guy did it in 9 minutes and some odd number of seconds.
Wow.
And we checked him; he's not a robot. So that was. We were like, wait a minute. Anyway, at the end of that set of pictures, after the awards from the finalists of the soldering challenge, there's a cool little walking robot that a student built that you might get a kick out of.
Okay. Okay.
Just wanted to share that. Thank you.
Yeah. Thanks, James. Okay. Yeah. Well, we might revisit that here. We'll see if somebody and other folks here have some stuff to share, and then maybe we'll come back, and if we have a little time, we could hit some of those. Okay. What?
I've got one, Steve.
All right, go ahead.
I just realized as a co-host, there's no raise your hand option.
No.
So I'll jump in here. Let me share a screen real quick. That one. So hopefully folks can see that. You should be seeing a screen that has the book Vibe Coding on it. So that's just a book that I read the last couple of weeks. It's essentially it was reasonably good, so I thought I'd pass it on as folks were this is a lot of chatter around vibe coding and how to do it and how to use an AI while coding and so forth. And this friend recommended this one to me, and passing it on. It was reasonably good. A little disclaimer, you'll note on the title, it was written by the CEO. It was actually written by the CEO and co-founder of Anthropic, which is the Claude programming model. So it is a little salesy, especially the first part. But it was, $17 on Kindle. And it was worth reading. And I learned a few things. I've changed the way I kind of use the AI a bit from it, and it also talks about bigger things that you can do and pitfalls to watch out for and so forth. So thought I'd pass that along. I'll drop the URL link into the chat window.
Okay, thank you. Yeah, I was seeing. Looks like you can get it for under $20 on thrift books, and you can also get. Looks like Audible has it, so there's a variety of formats that are available. Yeah, please do that. Okay.
Okay, it's there.
Thanks. All right. Anybody else?
I'll just mention quickly, I'm going to be doing the full presentation in January on the Mobot. That's the avatar that you see for me there, as well as another robot that I'm working on, which is a Scotch broom puller. The Mobot here is started out as a RC lawnmower that I purchased at auction, and all I've done with it really is add the ArduPilot ecosystem to make it fully autonomous. So it's relatively easy to do. It just took a handful of money is all. But the Scotch broom puller that started out as a mini excavator, and at this stage is a remote control Scotch broom puller, but it's not autonomous yet. I got a long way to go for that.
Okay. Well, we'll be we're looking forward to that. That should be fun. Okay. Anybody else got something that's they're just dying to share? Going once? Going twice? Okay, I think before I jump into my videos here, I think I want to open James' link there to the photos, and maybe he can just kind of talk a little bit through some of these pictures. I'll go ahead and just
Yeah.
play the Google Photos here from my computer. So let me share the screen. All right, so share.
So I'll just say that this first picture is of a guy who is somewhat representative of the kind of people who come to this event. His name is David Shorley, and he is big in the Hollywood film industry. He does all kinds of photo effects and like post editing of video and that kind of stuff.
Are you? Let's see. Nobody's seeing anything yet, right?
Oh, does it help if I share the window?
Yeah. Why don't you?
Are you guys seeing that screen sharing now?
Yep, we're seeing it there. Okay.
So this is the guy I was talking about, David Shorley. He's a great guy. I don't know if you can see this. Let me see if I can zoom in a little bit.
He got on his head there.
But so what he likes to do is he 3D prints stuff with fabrics, and he's now expanded out to 3D printing stuff with chainmail. So what he does is he's like starting the 3D print and then pausing it and putting in the chains, right? And then continuing the 3D print. So they're embedded in it. And he's done the same sort of thing with cloth as well. So, and this is the alleyway where the bulk of the event goes on. This is from Hackaday SuperCon in Pasadena, California, which I really recommend anybody who can afford to, come down and attend the event. It is my favorite event. This is Hong Yang actually, and this is last year's soldering challenge badge. All of those LEDs actually work all the way down to the 0201. It's not lit up when I captured it, but this is the badge, which is kind of a version of Meshtastic. It's not actual Meshtastic because there was going to be 500 plus people in a tiny area. So that because like the whole thing with the mesh radios, what do they call it? LoRaWAN, I think it is that it's like you get miles of range out of these things. Therefore, this is kind of a post-apocalyptic communication thing. It doesn't need the internet. It doesn't, it's just totally on its own. So they invented their own protocol, but they're working on an upgrade to actually convert it over to the Meshtastic LAN system. Which, if you haven't looked into that, anybody who's interested in remote robotics, I mean, that would be an interesting way of like giving your robot a new waypoint to go to, or getting back sensor readings or something. It's very rate limited. You can't like do video or streaming data or anything like that, but for low range stuff. So this is the soldering competition. Here is the part. So you can't even see it, but I don't know if you guys can see my cursor, but this little white dot right there in the middle, that's the part. There it is actually working. This is filmed through an eye loop so that you can, see it. But you get an idea of, what the size of the components are from the larger ones. There you can see the pad. If you look to the left of D3, you'll see the single pad, and then you see the double pad, and the little teeny tiny black gap between the double pads, that's the size of the component. So if you look down to D4, where that gap is on D3, you can see the gap is filled. That's the component. That's the LED, right? So that was hand soldered down. So this just gives you a sense of like how tiny that is. There's another view with like just live with a quarter. So you can see, we're talking smaller than a grain of sand. I mean, this is just, it's incredibly tiny. The sizes in millimeters. So that's point. Is that right? Is that size in millimeters? Yeah, I believe that's correct. 0.2 by 0.1. So this is 0.1 by 0.05 millimeters is the size. And that was soldered. I watched him do it. That was soldered with a standard Hacko soldering iron and flux. There's the the finalists. Hongye made it into the finals. He didn't get the tiny part soldered down, but the other ones. And it's this guy right here. He's the guy who actually nailed it. And then there's this guy's little robot walking around. That's made by a graduate student at one of the universities. He enjoyed the use of like toddler shoes. They use like baby sneakers to provide the padding on the feet for the grip and all that. And yeah, so he said the hardest part of the whole thing was getting it to actually like do the walking, and it's all trained neural networks, combination of simulation and then actually just doing it with the live thing. So yeah, SuperCon, Hackaday SuperCon. If you get the chance to go to it, I really recommend it. It's an absolutely amazing show, and you literally will meet the best of the best people there. And if you're involved in electronics, like BitLooney comes every year, Krasno comes, Jerry Ellsworth comes. These are all people that you might recognize from their YouTube channels. These are all like really top end electronics guys. Robotics is sort of not the focus of the show, but it's involved in the show. So, yeah.
When is it going to focus?
Yeah. My grandnephew is sitting next to me here. He's the fuzzy blur that you see. It's like you got to love Zoom. And it's,
Right.
Have you seen a doctor about that skin condition?
yeah. It's yeah.
That's great. Well, you're lucky to have a grand uncle like Steven who can
Yes.
teach you all about electronics and robotics and all the good stuff.
We built a kit last night. One of these listening things with the dual microphones on it, and then a real sensitive amplifier. So we were playing around with. He'd stand at one end of the house, I'd stand at the other end of the house, and we could whisper from like 40 feet away and understand what we were saying. It's really cool.
That's great.
Yeah.
Good.
So
good for listening in on your sister, figuring out what she's actually plotting against you.
Right. So I am curious. So this guy did most of the soldering on this kit, and this is like a kit with actual real resistors and real capacitors and things like that. But how in the world do these guys handle those teeny tiny little parts? I mean, I'm picturing even one of those with a tweezer would be extremely.
Well, I'm not sure if I'm allowed to give out the. Yeah, I should be able to get away because you guys are all in Seattle. It's okay. You can't share this with anybody else. So the first thing is you tape the board down as soon as you get it. They have like masking tape, so you tape the board down so it doesn't move, and then you have the flux pins, to flux the connections. What some of the people do, when I competed in it, and I did okay. Is you just flux the whole board. Just put like 2 layers of flux over the whole thing. And then as you're getting your components out and getting ready, you're letting that flux get tacky. And that helps to hold the parts down once you place them, right? So you've got a little pair of tweezers and you get your parts out. You can put those down on an upside down piece of tape if you want to hold them down, but you have to be a little careful because you'll get the sticky of the tape on the component, and that can be a problem. So then what you want to do is get just a little bit of flux, just the right amount. It's really difficult to do this. You have to get just the right amount of flux on the tip of the tweezers because you can't pick the part up with the tweezer. That doesn't work, okay? So what you have to do is you have to just touch the part with the tweezer and get it to stick to the tweezer. Then you put it onto the board, and because there's more flux and 2 pads as opposed to just the one, point of the tweezer, it sticks down to the board, right?
Yep.
Okay, yeah. I forgot to mention what you want to do is put a little teeny tiny bit of solder on the pads. So you tend the pads, then you flux it, then you get a little rosin on the thing, move the part over, get that stuck down. And then what you do is you don't try to put the soldering iron on the part. You put the soldering iron on the next pad over on the trace. Okay. So you've got, if you look at the board, you'll see that there's like little short segments of copper trace between like the resistor and the component. And there's a test point over there, which is, looks like it's just a test point, but it's actually there for a reason. So what you do is you put the iron on that, and then you basically let that reflow the solder and the flux. You have to be careful not to have too much flux because you can knock the part off. If the part is large enough, you can hold it down with the tweezers as you're soldering it. But for those smaller parts, if you try to do that and the tweezer slips, you get this doing, and then that's the end, because you will never find that part again.
Right.
Like, God forbid somebody sneezes or coughs or or anything like that. You know, it's gone. And we actually one year had a guy, because I've done this like multiple years and multiple sessions, and I just love it. We had a guy who dropped the 0402 on the floor. And keep in mind, this is like a, standard cement, dirty floor, right? And he soldered all his other components down, and then he got down on his hands and knees with a jeweler's loop and started looking for it. And everybody was like, dude, there is no way you are not going to find that, right? And he actually found it. Got back and soldered it on. It was like a 1 in a million shot that he was gonna. He's like literally moving in an like inch by inch grid over the floor around his chair, trying to figure out,
Oh my goodness.
Wow.
Generally you're not going to find it. So yeah, that's all the secrets that I know. That's all the tricks.
Okay. Well, that's got to be something to watch. Now, so do they have like a microscopic camera that's projecting this up on a big screen or something so you can watch what they're doing?
No, you have to just carefully stand behind people and watch as they're working. It's not.
See, that would be pretty neat. I mean, I'd love to have a little, like one of those circuit board cameras that magnifies and then be able to actually watch them. What the magic they're doing there. Wow, that's amazing.
They did have a guy, a professional guy, take some video of the event, but he was like, yeah, I'm not set up for this, different set of cameras, and you didn't want to interfere with what they were doing.
He's like, I will not touch it.
Yeah. Wow. Well, thank you for sharing that. That does sound like a really fun and interesting event to attend.
It's my number one favorite event of the entire year. I absolutely love it. It's the smartest of the smartest people, and truly recommend it.
Okay. Well, that's good to hear. Okay, so how? Let's see. Anybody else got something they're just dying to share?
Just speaking of soldering, I'm wondering if anybody knows whether or not the Snowco Makers Group has an induction solder iron. Or an induction
I don't even know
station.
what an induction soldering iron is, and I thought I knew all about this. What's an induction soldering iron?
It's one that heats the solder through induction rather than a heated tip. So by sending a waveform through I haven't used one myself. I only looked it up as I was attempting to solder a 40-pin aircraft connector for my Scotch broom puller. And I got one soldered well enough just using a traditional solder iron, and the second one didn't go so well. And so I stumbled across the induction solder iron, which allows you to get into tight spaces with lots of wires without melting everything around what you're trying to solder.
Oh, so it's a more directed application of the heat. So you're not burning the adjacent.
Exactly.
That's really interesting because normally I think of an induction cooker as being something that cooks like a wide, like on the stove, right? You
Yeah.
would cook a large area.
Say, Craig, does it look does it look anything like any of these?
Not the one that I saw, but these look like more wide, as James is describing. You know, they're going to hit wide areas. The one that I was looking at was allowed you to get into really tight places.
Huh.
Interesting.
I'll have to look around and see if I can find something.
Yeah, yeah. If you find anything, specifically like what you're looking for, Chaz Eiler runs the Sunoco Makerspace, and he's normally here at our meetings. Unfortunately, he's not here today because he would be able to answer your question, I'm sure.
That's really actually quite interesting, and I will have to look that up. I can't find him either. So if you find that link, maybe you can toss it in the
Sure, will do.
chat or something.
Will
Yeah.
do.
See, it's like some of these, like this particular model here has different sizes of coils. Although they don't go down really small. It looks like they go down to I don't know. It doesn't, it's not saying what the diameter of those coils are,
If
but
you go down, they usually have that information.
Yeah, when I was doing my research, the cheapest one that I could find that looked like it was suitable for what I was trying to accomplish was in the $1,500, $2,000 range.
okay, yeah. So these look pretty cheap by comparison. Yeah.
30 seconds.
And it looks like these are designed for bigger, larger soldering jobs too.
Yeah, in fact, I've taken some classes out at Clover Park here in some mechatronics courses, which is right next to their machine shop. And in the machine shop, they were using some induction heaters for heat treating, like you saw in that one. You saw them heat treating a bolt.
Yeah.
And induction heaters are very good for that because they heat up your components so quickly.
And of course, what I would find out about these bolt heaters, the week after I had to drill out a bolt because I couldn't get it out without rounding it off. So, where were you a week ago, buddy?
Oh, riding the mountain bike.
That's actually really useful to know about.
Yeah. Huh. Cool. All right. Well, we are at a good time to take a short break here before we let Jason share with us about his stuff. So let's see, what have I got here? If I all right, I find I usually have a clock of I know what I can do. That's right. I will go back up to. Oh, I don't have the time on there though. I usually put a clock on the.
You know what you do, Steve, is just let me start talking, and then about the time that everybody's sick of hearing my voice, that'll be the time to start.
Wow.
Yeah, that's yeah.
I've got a clock I can probably share if needed. Let me see if I can
Well,
find it
I've
real
got
quick.
actually up in the upper right corner of this screen there. You see, there's a little clock. It's showing Mountain Time, but I'll let you guys mentally subtract an hour
Okay.
from it. So, yeah.
I want to do the Lego building a Lego pad summary.
Okay, so let's all reconvene here. Let's call it, I don't know, three past noon by Mountain Time. Give it about that'll be about 7 minutes or so. That's enough time to run to the restroom, grab a cup of coffee, whatever. So
Sounds good.
so let's about 12:03 we'll restart things.
posted another link there for the Hackaday SuperCon in case anybody's interested. Did anybody watch the big flying robot land itself on the boat that wasn't the SpaceX one? The Blue Origin finally managed to actually land the booster on a robotic ship. So that's a robotic rocket landing itself on a robotic ship, which is pretty cool. That there's some competition. Of course, I don't think it quite rises to the level of a robotic booster being caught out of the air by the largest robotic arm ever made, period, which is the 2.5 or 3 degree of freedom Mechazilla tower that SpaceX launches the Starship Super Heavy from, and then one time so far caught the booster out of the air as it flew back down again. And then they use it to stack the ships. So it definitely qualifies as a robotic arm. And it's pretty impressive if you haven't seen that.
And the fact that they can reuse one of those rockets after it's been through what it's been through, that's amazing.
Yeah, they just expended one that had gone, I don't remember what the record, it was like 20 something times that they had used there's a Falcon 9, not a Super Heavy, but a Falcon 9 that had flown 20 something times. Let's see what it is. 31. The record for the most flights by a single Falcon 9 booster is 31, set by booster B1067 on October of 2025. That is unbelievable to me. Truly living in the modern age here with Flash Gordon rockets. So I just looked this up out of curiosity, and they have attempted to land a Falcon 9 booster 546 times, and they have succeeded 533 times. So that means 97.6% accuracy. So the question in mind is, would you ride on a Falcon 9 booster and come back down for the landing? I think I'd take the chance. 97.6% chance that you'd survive it.
Well, I think part of that depends on how many of those failures occurred during the early stages versus the late stages of development.
Oh, good point. Good point. I think a lot of the failures were early on, right? So it's actually probably a higher percentage chance now.
Yeah, how many out of the last 100 failed?
I don't have that number, but I think it's pretty high. Now the question is, where would you put the chair? I don't know what kind of G load would you experience, and you might successfully return as a flat object.
Wasn't that big part of the reason why they didn't send the astronauts back down in the Boeing, whatever you called it, their shuttle, was because the environmental controls for the astronauts was not up to par?
I'm not going to comment on a Boeing product in front of a group in Seattle. Y'all have been very nice to allow me in the group since I'm in San Diego. So
Yeah, you're one of them California guys. Well, I don't know about you.
Yeah. I mean, I did grow up in Oregon and around Portland, but
I did too.
Well, there you go. Okay.
yeah, keeping it weird.
Yep.
I don't know. Given the situation in Portland these days, sometimes I wonder.
We are ready to launch into our presentation. So let's see. Let's see. Am I still? No, I'm not sharing anymore, right?
All right.
Yeah, there we go. Okay,
See it?
Jason.
All right.
Yeah.
All right. So yeah, really appreciate the opportunity to get to talk for you guys and show you what we've been working on. What I'm going to do is talk a bit about the technology and the solution we came up with, and then most of it will be in a demo. And in that demo, I'll kind of start at a high level of the solution, but then dive down into the development process and things like that. And you guys feel free to jump in, ask any questions, and I will get started then. Yeah, so I'm Jason Seawall. I'm CEO at Numerous. And really our goal at Numerous is to take a lot of these technologies that are out there and available and needed to make autonomous robotics or autonomous solutions and make it easy. And I'll talk a little bit about my background. I've got a slide that'll kind of show you, talk about why we're doing this. So, all right, let's see. So one thing to I think a lot of people don't realize, we hear so much about AI. Most of what you hear on the news and all these, new apps and capabilities, it's AI running in a cloud. And so it's running, it's amazing what they can do. But it's running, on a bank of servers sitting in a room somewhere. And so that's great if if you've got constant connectivity or connection and the money to do that. But if you're on a robot, that's not going to do much for you. And there's not only the processing and communication. It's to make to take real-time actions, you need to have the shortest, lowest latency time between detecting something and taking an action. And so for that, for those that aren't familiar, well, there is a NVIDIA and a number of other companies now who make these embedded GPUs. And so you don't have a server of a room full of servers running GPUs. You've got one little chip that's sitting on the robot that needs to minimize the amount of battery power it uses, but provide again that the types of information needed to make those autonomous decisions. And so there's this is a picture of an NVIDIA. I think there's an Orin NX GPU module in the little carrier board. But even on a Raspberry Pi, you can run AI. It's a matter of obviously that latency. And so just for reference, for those that are not familiar with the NVIDIA boards, a good Raspberry Pi system, I think maybe $300 at a higher end. But these NVIDIA boards and chips, they are, they can get into the thousands of dollars. So, some of it has to do with, price, and they are higher power and things like that. So just what I wanted to do is just talk a little bit about my background and why we're doing what we're doing. So actually, I got my degree in mechatronics, my master's degree in at the University of Texas in Austin back in the day. This was my robotic project then. It had a little Motorola processor on it. It wasn't quite working at machine language level, but it was, there wasn't a lot of tools, and but my project was fuzzy logic control system for it. And at the end of the, when I graduated, I realized I probably spent 80% of my time just hooking up all these sensors and motors and, how does someone interface with it? I and I didn't realize it directly then, but I was pretty disappointed, like, wow, what the cutting edge research I was doing was in the fuzzy logic development, not in, how to hook a motor up. But went on from there, I got a job at the Applied Physics Lab in Washington. And working on there, I don't know, for those that aren't familiar, they do really focused mostly on marine, and they do a lot of robotic marine work at the University of Washington. And there, started working on a number of different robotics projects. This was a marine crawler, so it would crawl into the water and look for mines. And then from there, worked on a lot of different robotic systems, some of them, like submarine types. This one here on the left, it looks like it's, a cartoon or something from Disney, but it's actually a robot that DARPA-funded robot for repairing underwater communication fiber optic lines. You know, if we go to, if we get into some type of a war or something, cutting those lines is going to be one of the first objectives of our adversaries. And so it's actually pretty cool robot. That's an actual picture. And we actually developed the eyes and the brains, not for controlling the robot, but for providing the robot with, what's in front of it and what's the distances. And then, just a whole bunch of other robotics projects that I was involved in. But really along the way, the only difference between all these projects was the end capability, the automation specifically they were trying to achieve. 90% of every one of them was the same. I need to hook up to a camera or a laser, a sonar, GPS, and INS. I need, maybe it's controlling lights. I need to talk to a control system, and then run my processing. And I need a way, because, these chips are sitting inside a vehicle. I don't have a keyboard and monitor there, so I need a way that I can log in. And what I saw, starting from that first project when I was in grad school, all the way until I started Numerous, was that, myself and customers, they would get a bunch of really great equipment and processors, and then they would spend months and years, just getting to what they wanted to achieve, right? And so that's where started Numerous to do. And but there's you talk about AI, but there's different types of a lot of computer vision capabilities. There's AI is not the all-encompassing component for making an automated decision, but it's definitely quite a powerful tool in the toolbox. And so if we just look at that as what you have, if you train, if you say either you did it or you hired someone and you got an AI model. And I will say we've got it's not hard to train an AI model either. But what you end up with is a file, and essentially, if you hand that to someone, what do they need to do to actually turn that into an automated solution? And so, one of them is hooking up, obviously the sensors, navigation equipment. There is a lot of image and other data that needs to be managed and I guess connected up between different components. You ultimately, you want to control something, whether it's just moving a motor, a pan and tilt, or a robotic, some type of a control system, an ArduPilot, a flight controller. You need, different applications, whether it's AI or different types of processing applications. And then again, you need this user interface. And so all of those components, every project has these components, not necessarily to the same level, but they're all the same, every project. And it's really, now that I've got my AI running, all the sensors hooked up, I've got a way to interface with it. The real project, and most people, what they, when they go down this path, they want to obviously just, it's that last 5% of the project that actually what got them really excited to begin with. And so this is what, while there's companies out there that focus and they're experts on creating these files, what we are trying to achieve is to make this outside, everything that goes around that. And so we created a software called NEPi. It stands for Numerous Edge Platform Interface. It essentially really, one is not only doing that, but doing something that you don't have to be a computer scientist to actually use. If you are, you can dive as deep as you want, but you can, out of the box, take something and be running with your AI, controlling something, and then, learn as you go and, change it. So, and one of the things that a good term, and a lot of people hate it, that are computer, really hardcore computer people, is I call it Windows for robots, because back in the day, I had my first PC. It didn't have Windows, it had DOS, and you logged in and you had a blinking cursor, and it was cool. I was an engineer, I loved it, but to most of the world, it was not it was just they really didn't know what to do with it. And so if you look at these embedded chips, a lot of it's the same. You have, why they come, most of them come with some type of a Windows-like interface. It's really, all they've done is taken a desktop or a laptop, that type of software interface, and put it on the chip. And it's not, it just really, it allows you to go in and work in that environment, but it's not what the it's very far from what people working on robotics and automation need. And so what we've done is along the lines of, very similar to Windows, plug and play on the hardware. So with your laptop, you can plug in keyboards and printers and things like that, but you don't need that in a robot. You need cameras and lasers and navigation and pan and tilts, control systems. And so NEPi actually, it's got a driver library that auto detects and configures those sensors, makes the data available. It's got a whole data management system as well as AI management system. So if you've got that AI file, you can drop it in a folder and link it into the system. Essentially automation processing. And so, again, because an AI is sitting there detecting something, it's not very valuable unless you're taking some action. So we've got an automation management component. And then user interface. And so, once again, you don't have, typically you don't have a display hooked up when these things are doing their job. And so you need not only a way to interface with it remotely, but you need a way that somebody that that's not an expert in Linux can actually use. And yeah, and so that was our goal. And so so the software platform, again, called NEPi, what we do is we run on like this is one of those NVIDIA chips in a little box. We run a web server on there that provides the the network interface. to all the software running below. And so this is just a quick video highlighting those 4 components. And so again, this is, cameras, pan and tilt, robotic like RG pilot, control systems, lighting. And so, once the system automatically detects it, you get, you can open up one of those windows and manage it. Again, managing your different AI or the different processing you want to do. And then ultimately, taking some action, whether it's tracking something, turning, alarms on, doing a robotic inspection. And I'll actually, again, with the demo, I'll do that. All right. Yeah, so, user interfaces are great, but it's, and obviously that's one way to interact with it. And it's actually quite important while, one, you're developing and setting things up, but 2, obviously, when it's out doing its job, you want to be able to interface with it. But ultimately, a human is not necessarily, and most times is not in the loop. It's just a matter of, they're there monitoring or configuring. And so you need to, you need to be able to, all the things that I was showing need to be programmable. And so one is we have a low code API. It's all Python with a lot of libraries to essentially, simplify interfacing with these different devices, the AI, and taking actions. But if you go down one step lower, the whole thing is built on ROS, and we've got a ROS 2 version coming out. And so everything you see, all the data, all the controls, there's a ROS API connection point that you can interface with. And so very easily integrate this into an existing or new solution. And what we don't do is like, we're not a robotic control system company. We're essentially, we do like smart payloads. So you've got a robot that can drive around, but the robot, what do you want the robot? Why is it driving around? What are you looking for, and what do you want? What action do you want to take? And so that's really our focus. I'll show you a couple demos, customer demos, or customer use cases. So there's a marine surface robot that obviously unmanned, and it can go out and it can stay. It's got covered in solar panels, so it can stay in an area quite a long time. It can run different tracks. But ultimately, obviously, the customer is not spending all that money just to have a robot drive around. It needs to do something. And so they put our software on one of these boards in all their systems. And so when their customers come and say, I want the robot to do this, they very quickly can, can help the customer or send them to us to actually, develop the ultimate solution they want, which is essentially, coming up with the different types of maybe AI models. What are you looking for? And then quickly scripting an automation solution on detections and things like that. And so this one, we had one customer, they say they have 4 cameras around the vehicle. And so they set it up so that there's 4 cameras are just cycling through their AI model. If they detect something, then the system would ask the vehicle to stop and hold station for a second. And then it would turn a high-res pan and tilt, high-res camera with a pan and tilt at the, target of interest, and take a high-res picture, get a GPS location, and then store that, and whenever they have communications, send that out. And so, this is just one use case, but again, this is ultimately what the customer wants, hooking all those things together, all the hardware, and that there's nothing different from this case to any other automation case. And so it's really, again, that 5%. One more. So we work with a Lane Community College, they've got a drone program there, and these students, they really, most of them, don't have little to no programming experience, and so we work with them to again bring in these kind of technologies, AI and automation, into their projects. And so one of the students we worked with, they wanted to do a search and rescue drone, and so what the setup was, so you could choose, like, if you're looking for a person that was wearing black or red, choose those colors, send the drone out on its on a track, and our system would just sit there then monitoring the cameras, and if it detected something, it would again ask the drone to stop, take a high-res picture, get that information, and then send it, or store it and send it as soon as it could to a remote operator. And so that actually working, and this was a couple of years ago, working with these students really was eye-opening. I mean, even to myself and our team, these technologies are just working in Linux, and having to bring all these technologies together it's just really difficult and time-consuming. And then trying to make those technologies and capabilities available to to students that don't know how, aren't just learning how to program. It really was amazing, and to think of the gap between most people and the availability of using these technologies. And then the other thing, again, trying to make this easy, is we've got a lot of development resources. So we've got obviously GitHub. Most of the software is open source. Just some of our applications, drivers, and then some of the package solutions is what we sell. We've got a community that we're about to bring online. A lot of documentation at the NEPi website, tutorials, videos. Then for a lot of companies, having access to support is huge. So their engineers are not sitting, for anybody that has done much programming, you can, when something doesn't work with some open source package, it typically you're not, there's no one to call. You're just searching around for, hours, if not days, for that solution, to find somebody else that had that same problem. And so I think from there, I'm gonna switch computers in a second and jump into a demo. Oh, actually, I did want to say one thing that we've been working on is the software. Originally, it all installed on the chip's operating system itself, which tied it, pretty tightly to whatever hardware that you were working on, in a lot of configuration. And so we were about to launch a containerized version of that. And for those that don't know, a container is essentially just it's a bubble of software that pretty much has everything you need to install it and run it, as opposed to having to install, 50 different software packages and wonder why things aren't working and talking. And so that really, again, going towards how do we make it easier for people to use. And so if anybody's interested, you can go to this site or reach out to us, and we're looking for people that want to test out our not only our container, but the integration, documentation, and things like that, to help us really get it again as easy as possible. So yeah, what I'm going to got set up here on the workbench is one of these boards. I've got a little, just a webcam here, and a little pan and tilt system. And then I've got a laptop hooked up, just an Ethernet cable to that system. This system doesn't have Wi-Fi, so our software also supports like a Wi-Fi access point. So you could actually, it would show up as a Wi-Fi that you could just log into. So I know there was a lot. Any questions or anything before we jump into a demo?
Can you share what exact board that is so we can have a sense of what the cost of it would be?
Yeah, actually, this is an Orin NX Seed Studio, I think FJ410. But it's really the boards themselves. I've got a pile of different boards from different customers and projects. The boards are cheap. There are. It's really just a bunch of resistors and and components. It's this board I think is $150. The GPU on there is, I think we paid $1,000 for it. So it's really the processor that drives that, as well as there's a little, well, you see that demo, that's our SSD, and so I think that's a 2 terabyte SSD. So that's about $300. But again, it's NVIDIA has the Jetson Nanos, which are obviously much lower power and capabilities, but they run, I think they run less than $100. So you can get started with one of these without having to, break the bank. All right, so let me just switch computers here. I've got
Can you guys hear me?
A little bit of echo there.
Yeah, that's what happened with 2 computers.
Let's see here.
Yeah, if you mute one of your computers, it ought to work out a lot better.
Yeah.
Yeah, I'm trying to.
Let's see.
Okay, great. So I need to share this. Okay, can you guys see my screen?
Yes.
All right, so the
So just to clarify before you get started, is this the screen? This is the screen on the laptop that's connected to the module.
This is the screen that's on the laptop, right?
Yeah.
Yeah, so it's just a normal laptop. I've opened up Chrome, and the only thing I've had to do is go in and just set one of these Ethernet connectors to the right IP address. And then so the system can, they can talk together. From there, then I can just select the website or the IP address for the system that I'm working on, and I get a user interface here. This is just, let me zoom in some. So a dashboard tells you some information about your system, any of the messages that are running on it, just kind of the useful stuff that you might want. So in this case, I've got got the camera hooked up, so it's auto-detected the camera. I can come in here and turn the camera this way. And a lot of capabilities being that I can change. I've got access, whatever the camera publishes as far as configuration. I can things for like the imagery. I can turn on overlays whether it's, these built-in ones or send custom ones to it and change the size. And again, what's really cool is everything you're seeing there, that's a back-end interface and a ROS interface for it. So every control here, I can turn on this auto adjustment, is something that could be part of your solution. Obviously, the goal for these cameras set up is just setting up. Does it work? The other thing is, turn that off. Saving data. So again, this if so here's a snapshot control. So again, there's an API for that. You could have your automation taking snapshots. I can if this was like we work with, I don't know if anybody's familiar with the Z stereo camera from Stereo Labs, but we support those. So we support the 3D data that comes from that. And so those produce a lot more potential data. And so I can select what data I want to save. I can select a rate. And again, I have a control and an API interface that can control that. Okay. Let's see. So navigation. Well, we can come back to this. Oh, that's data. We'll come back to that. We've got a nav pose manager. So any INS or GPS that you've enabled, that data would be available, and you can configure, the offsets and things like that. And again, the way to think about it is any location or pose information. What we do is we define, or the user defines, essentially, we call it, the base location and pose, and then everything else can be, you can enter the offsets to get to that. Processing. So I've got an AI model that I turned on. So come over here, look at any of the AI models that are turned on. I can select, it'll show me any of this one obviously has a lot of things it can detect. So I can do, none of them, all of them, or just, control that. This case, I only have one camera. If I had 4 cameras, I could pick, which cameras or which streams were coming in. But go ahead and just turn on that AI model. And again, you can see, everybody's seen pictures of these AI detections, and the final step of taking the image and running it, it's one line of code is really easy. It's actually to get to this point that takes all the work, where it's turning into a useful tool. Yeah, so controls for the different AI controls. And then automation, while we have apps, I may have one on here, we've got this automation manager, and I'll show you this, but this is where you would put your Python or other scripts that you want, sitting there, looking at the output of the AI or some other state or some other situation on, from the system, and then taking some action, controlling, a motor or sending an alert, turning a light off and on, telling a robotic arm, where an object is in the world and what pose it is. But this, so again, this is, when I was working in that fuzzy logic control system in grad school, this is where I needed to be working on my algorithms and dropping them in here. And so, that and other projects were really the inspiration, where that first picture I showed with the circle and the things around it, this is what's different for every project, is what is happening in these automation scripts. And so we, imagine NEPi is essentially again, this bubble around those. The other thing is, to actually use these systems, there's a lot of things that need to be managed. So device management, and very similar to, your laptops and things like that. I don't, well, it's not shown right now, but you can control your IP address. If they have Wi-Fi, you can again set up the access point or connecting. Set up if you have an NTP server for syncing your clock with other clocks on the system. That'd be managed there. Software, what happens when you need to update software? What happens when your software runs into a bug because you introduce some new change and it doesn't work? And so we manage essentially a dual partition, or with containers, two containers that if one of them fails and doesn't boot, it'll switch automatically to the backup. It also allows you to have a container that you're developing on and testing and switching back and forth. And then if you have something that you like, you can actually just click archive it, and it will export your software as a container, as a tar file that you can share with other teammates or other people in the community, which makes it really easy to again work with teams and things like that. Pose we talked about. So device manager. So all these things I'm showing you, they all take resources, and so this is just showing some of the drivers that we support. So if I look at imaging, like the Z camera, USB camera, ONVIF camera, Jenny cams. So each one of these, all these different cameras in the world, they don't all talk the same language and stuff. So you need to write an interface for it. And what we do is, and so every imaging sensor, whether it's a camera or a laser, and it produces an image, we've got a common API interface. And so once that our driver or the driver for that component connects to it, what comes out and the controls in are essentially the same. So if you're developing an application, you don't need to know what type of camera and stuff it is. Pan and tilt. So yeah, this is that one I have. And so again, none of these, if they're not highlighted, they're not actually running in the background looking for it. So I'm going to enable this pan and tilt driver. I can go back to my dashboard if I wanted to see what the discovery and setup process is doing. And I think that's done. And then a couple other things. AI models. So like all these different models out there, they actually have, they're kind of like different, familiar with JPEGs and versus a PNG and things like that. They're developed in a certain, what we call a framework, and they need to then run in that. And so we can manage different types of models. I can enable that framework, and then any of the models that fit that are available, and I can turn those off and on. And so these models, when you enable them, what they're doing is being loaded in the GPU, and you've got a limited amount of GPU. So you may have 20 different models that you need to switch between during a mission, but you can't, and you don't want to load them all at once. Finally, applications. So I think we've got a few on here. And again, you want to be able to turn on and off applications on the fly. Let's turn these. Let's turn this. Okay, so those applications are loading up. And if I go back then, let's go back. So now it's found that pan and tilt. Select that. I can select the camera that's on there. Let's just select that guy. And so I've got the controls for the pan and tilt. I can set automated. Where's that not working? Oh, that's reverse. So I could set, automated scanning and things like that modes. And these are all, and I should say, once again, all of the source code for all these is available. And so what we're aiming at is not, we don't know what our customers or our partners and our users want to do with the system, but we want to provide a 90% of the solution where they can go in instead of building all this from scratch, say, okay, no, I want this pan and tilt to, do this. But for those that have coded, having something that works and modifying it is a lot faster than building from scratch. So let's see. And then I've got, so I turned on some of these applications. So one is I can turn on, let's see. So a lot of times, you want to do testing, you need, you're not in the field, but you want to simulate that. And so I can, underwater. So I can essentially, from a folder, I can publish the images that are in there at different speeds. And while I'm testing, I can go forward and backwards on it. Same thing with, I haven't tested this. Let's see. Nope, that one's not working. But also, a lot of times you want to be able to see all your cameras and everything at once. Oops. So if you had multiple cameras, different types of data, you could view those simultaneously. And then if we just go back to the AI processing, pick that guy, and you'll see that now, all of that. Let's see if this guy, and this might be, let's take a second to connect to that, but you could actually then select, multiple cameras going through your AI. So that, yeah. So that's essentially, that's the front end user interface. And again, what we've tried to do here is create something that, again, makes it really easy to get to this point. And then from there, the other things, again, if you imagine this is sitting, in a robot, you need to be able to, let's see. I'm going to stop that again. So the system also manages a network shared drive system. So if I click on this guy here, this is actually the kind of the user area on my on that device. So again, I'm just hooking into the drive over the network. And this would be, if I had a new AI model, I would just drop it in here and the system would auto detect it. If we've got a whole training library for training the models. If you have a bunch of pictures, automation scripts, again, if you had different Python or executables or even bash scripts that you wanted to run, you could drop them in here and they'd be available. My data, any of the data that I collected, I can easily access it, download it. This would be if I exported an image I wanted to share or save, it would show up here. But again, this is, unless you've actually done it and worked with, things like SSH and SFTP, working with an embedded processor that you don't have a keyboard and mouse and screen on is can be quite frustrating and a lot of work if you don't know what you're doing. And then finally, I'll just kind of show a little bit of the tools. So at NEPi.com, we've got really this tutorial section really steps through for people that are new to the system. Again, coming at it with, hey, I've never actually used an embedded processor before. And so if the types of instructions and tutorials we provide is really designed for, for someone to learn as they go and not be confused right out of the, stuck right when they start. Was there anything else? But I think that covers most of it. And so, like I said, anybody, that's interested, wants to try it out, has, even, we'll be coming out with versions that'll just run, they can essentially run on your laptop or even a Raspberry Pi or something like that. Happy to, to help you guys out. So, any questions there? Oh, you got a hand?
Yeah. So great demo. I love the user interface through a web browser. I've been not in this space, but in other spaces. I've been doing that for a number of years, and I think it solves a lot of problems. I really like that. You run a little web server and then you use the browser to hit it. So it's nice to see people taking advantage of that. I had a couple of questions. You were talking about like how you're not trying to like keep people from getting down to the source code or whatever.
Yeah, actually, that's a good point.
Well, let me ask, like if somebody wanted to add a particular camera processing module, for example, maybe you can kind of just go over in general.
I am. Is my screen still sharing?
Yeah.
Okay, great. So actually, let's do that. Actually, that's.
And can I just point out maybe in doing this, you can answer my other question as well, because it's kind of related. So the demo that I always see with Edge AI stuff is the demo that you showed, which is the object recognition, convolving the frames and looking for things that match a particular template, and then drawing a bounding box or doing a mask or whatever, and saying hey, this is a flower, here's a pot, that kind of stuff. But even on a several $1,000s of equipment, the thing that I always notice about that is that the refresh rate on it is, maybe a few times a second at best, which is fine for what it's doing. But if you work with robotics, especially robotics vision and robotics arms and trying to manipulate things, that the speed of the control loop is absolutely critical. So you can't depend on like searching the entire image for the thing that you're trying to pick up in order to have a smooth actual motion of the arm to the thing. What you want to do is find the thing and then switch to something that's faster but more focused on that one particular area. So like blob tracking, or maybe doing some kind of frame subtraction motion trick, or something like that. And so I didn't have a chance as you were going through the available like systems to really see that, but that's the sort of thing that I would want to add.
Yeah, so again, what we focus on is the ability to rapidly load multiple, say, AI or processes, hook multiple imaging streams to them, and then allow our users to do, we don't do what, the solution you're talking about, but we support that solution. You can easily have one AI that's doing just a general, hey, I'm looking for something out there, and another one that's running on a subset of that image and doing a different process, or running a different AI that's tracking and trying to do some pose estimates. The other thing that we focused on is latency of data, low latency of data. So when you look at all the images that we're showing you, those images are running a different process. The actual detection is running in its own process, with as low latency as possible. And so while you may see latency showing up in the image because we're drawing boxes and we're converting things, the data that's, it's really, again, in an automated system, it's the data that you care about, and the latency of the data, not how the picture itself usually, right?
Right.
So I think, to your point, I agree with that. And I think every time we talk to a customer or a partner or a student, you know, they've got a different challenge they're trying to do, and we try to provide the flexibility to, you know, to do that. And so, yeah, if you look at the, if you go to NEPi Engine GitHub, you can see it's organized pretty well. So if you look at the main repo, and I'll actually show some of this. Well, here,
I'm seeing some kind of a Zoom workspace thing over the
I don't know
top of
what
your.
yeah.
Is anybody else seeing that, or is that just me?
Yeah, I see it too.
Oh, I don't see Zoom. Let's see.
I mean, I do see your desktop, but then over the top
Here,
of
let me
it.
try. Maybe try to share a different
Okay.
screen. Huh?
I think
Oh,
it's
there it
gone
is.
now.
There it is. There it is. That's it. That's what you needed to do.
Is it good now?
It's good now. Yeah, I'm seeing your NEPi Engine WS source. Yeah.
Yeah. Okay. So, anyways, yeah. So if you go to the page, really good instructions on like setting up. If you look at, and again, we try to make it so that it's well documented, good scripts, and once you download it, you can go to. Where did you go? Oops. Source. Okay, so you can see I've got the AI framework. So this would be, you know, if I wanted to add a framework, I'd add it in here, and it's really, we've got these APIs. So like, it's just a small amount of code that's in this that says essentially it's that interface between different frameworks, the drivers, IDXs are imaging devices. So you could, you know, take one of our existing drivers, modify it, or, you know, create a new one from scratch. And again, those drivers call a common API. And so the API class is what we're interfacing, you know, to that driver with. Let's see, source. The user interface system, again, oops. And then, so if this is cool too. Let me open up. So one thing is, so we've got with a container running on there, you've got a kind of a challenge in the sense that, you know, you've got the processor itself. That's all, you know, that boots up, and then you've got a container that starts up, and you want to be able to talk to both of them. If your container's broken, it's pretty, there's not much you can do if you're depending on that. So the other thing is, both for the developer PC and on the system, we've got quite a bit of built-in tools and things like that, so that, like, just if I want to SSH in to the host container, I mean the system itself, I can do this. I can look at my my installed images. I can, but let's actually, let me exit out of that, and then if I wanted to get into my actual container, actually, so now I'm actually in the container that's running on that host, and so I've got, you know, it's its own operating system. But if I want to, so I'm back on my system, so I can do deploy or NEPi. So I've made some changes to the repo. So this will rsync all those changes over to the system. I can then SSH into my system and do NEPi build. And it's now building out the software and deploying it. And then I just turn it off and on. And actually, I don't even turn it off and on. I mean, this will take, I don't know, this takes a couple of minutes, but you can imagine. And then I can just do stop. And, you know, and watch the whole thing start back up, monitor. And what's nice too with those controls in the user interface, you know, I can come in and like if I'm testing a driver and the driver's, I run into a bug or something like that, I can just go into that. Well, it's still booting up, but go in, turn that driver off and on, or turn it off, and push the a change, and then turn it back on without having to turn the whole system off and on. So anyways, yes, we try to make it quite open and available. Again, the whole point of this is that we don't know what you want to do with it, and what we're trying to do is produce something that helps you, solve your problem faster. So,
is there kind of a I don't know, like a blank driver kit or something like that would be like a good starting point, or is it easier to just like
yeah, I think it's
use
pretty
whatever
easy to.
driver and then
Actually,
adapt?
yeah, I mean, so every technology, if we do look at one of these drivers, like
so like
like a
find one of them
USB
that's
camera,
simple
right?
and just start from there.
Yeah, well, so if you look at, I'll just show this one real quick, is this is our node interface. And so let me just, what am I looking at here? Oh, actually, that's the driver. No, should have been in there. Maybe I missed it. Oh yeah, right here. So this just passes some controls like the factory settings, set controls for setting the functions, for getting frames, and then that's where the development is taking the manufacturer's library, and then just writing these standard API controls. Once you call that function, all of the everything else, all the API and streaming data and stuff like that, and then is all taken care of. So, but yeah, just we try to put a bunch of examples in here that can be taken as again a working template and adapted. All right. Anything else?
Anyone else have any questions? I have more, but I don't want to occupy.
Hey, Jay, does your website include a list of supported hardware in terms of things like sensors and navigation components, etc.?
Yeah, if you look at and so again, NEPi.com, that's really our software site. And then so you go to documentation, you can look at hardware driver support. And yeah, you can see the different, the actual, the programmable, the protocol interface that we support, as well as some of the systems that we've tested with, right? So we look at cameras. These are all the different types of camera interfaces.
So what would be the approach if I were using NEPi and I wanted to do something that isn't currently supported? Say, for example, I wanted to use a beacon-based navigation in my application under the forest canopy, GPS and LiDAR. I get mixed results. But
yeah, again, it would be just like this is our navigation ones. It would just be, again, there's an API call for, if I look at APIs, so NPX. So this is the class interface library, and all you have to do is come down here, call this in, and again, this is the interface. So if you've got whatever, we don't care what your system is, in a sense, as long as you can provide this information and these callback functions to get, to get the NEPi pose data. And these are all passed as dictionaries that essentially, if you've got a sensor or a system that has GPS but no pose, then you're just setting in that dictionary that those that those are not available. And then again, our API class takes care of letting the rest of the system know that. That makes sense? Somewhat.
Yeah, somewhat.
Again, it comes back to these example library. Everything makes a lot more sense when you have something that an example, right? And so which one did we just do? Oh, yeah, I mean, we just added, I don't think it's released in here yet, but just a standard UDP NMEA interface, right? And again, none of all those things, there's lots of little libraries and stuff for doing these different parts, but how do you make it one, easy and reusable so that, why is everybody writing the same interfaces for all these different cameras and spending, days, weeks, months, when really one person just needs to write one of them. And so what we're doing is, we do a lot of this in-house, but as we move to the container is really trying to create a community where people can create things, right, and help others out. We're also going to be in the part of Mate. I don't know if anybody's familiar with Mate Robotics next year, and we're talking to First Robotics to get a Raspberry Pi version that they can use in the competition.
I have one more question if there's time.
Yeah.
So the Jetsons, or the the NVIDIA development systems in general, I know a lot of people love them, and I know that a lot of people have had real good luck with them. My luck with those has not been fantastic. I've had a couple of experiences now where I've spent a bunch of time getting the an SD card set up, or getting everything loaded onto an SSD or whatever, and hooking it all up, and then having some weird corruption issue happen. And of course, being a professional developer, I back everything up. So, that's not a problem. And I was able to just recover from that immediately.
Yeah, no, but that's not true for everybody. Yeah. But there was no sweating, was there?
Yeah. Just to be clear, I'm completely lying. I lost hours of work. Anyway, so I'm kind of, and the other thing I noticed too is, despite the fact that they cost quite a little bit of money, the GPU is amazing, but the CPUs are kind of clunky on those. And so the developing on them is a little bit of a pain. I mean, maybe the higher end ones, it's not the case, but the what I'm trying to get to is this. Is there a substantive way to make use of this system, like on your PC, on your laptop, or on your mini PC or something?
Yeah,
like that?
it's just we just start with either an AMD, an ARM, or a Jetson container, and then it's all standard Ubuntu, Python, mod. There's nothing. It's just that Docker interface, and so you can drop this onto a laptop with a GPU, and again have that. Obviously, most people aren't putting laptops in their robots, but
But just for development, just to get started with it and learn the system and sort of play around with it, you don't necessarily have to go and buy the thousands of dollars worth of hardware.
Yeah, no, what I would say is that one of the things we'll be releasing as part of that test program is, again, just a generic ARM and a generic AMD, Linux container that you could drop on your laptop. And again, from that point, it doesn't know whether it's running, on an embedded chip or on your laptop, right? It's the same.
I think that's a really great thing to support for getting started. When is that actually going to be available?
I think that we're hoping within a week that's
Okay.
that's ready. And so, yeah, if you go to that, and Danielle, maybe you could email Stephen the link and stuff, or actually maybe you could put it in the chat. But
It's in the
anyway,
chat right now.
okay, yeah. So you can just sign up, and then we'll let you know when it's ready. And then again, what we're hoping to do is get feedback. It's but to your point, the reason that we've spent a lot of time trying to create this containerized Docker solution is because every time we get a new board from a different manufacturer, we'd spend
Right.
weeks, just to your point, unbelievably hard, where it's just like, oh my God, why is this so hard every step of the way?
That's so true. I mean, I really thought that I was really excited about a lot of this stuff when I got into it, and my excitement has severely waned as I
Yeah.
started to find out like just how unbelievably complicated those
Yeah.
ecosystems are and how little anyone has spent time sort of like standardizing things or
Well,
like
well, that's what we're trying to do. Again, imagine not only how it is for us with some experience. If you've never used Linux before, if you are a teacher that's trying to teach this types of technology, there's quite a big technology gap out there for people with a lot of experience, people with little experience. So, anyways, yeah, I'd love it if you and others signed up and give it a try. So, anything out there?
Thanks, Jay. Very cool.
Yeah, thank you. I really appreciate you taking the time, and reach out to me or Danielle. I didn't introduce Danielle, but she's our sales and marketing director,
Yes.
and she's running this container test program and things like that. So,
Okay. Yeah, thank you. I just
All right.
looking at the website at that link there, and so it's yeah, it looks interesting. So if anybody
Awesome.
anybody wants to jump in on that, please do be.
Okay.
All right.
Thank you.
Yeah, thank you, Jay. That was that was pretty fascinating. It's we have it's the Seattle Robotics Society over the years. What we've really figured out is that the software side of making these robots is always the hardest piece.
Mhm.
Making motors spin, yeah, that's not so tough, and reading sensors, yeah, that's not so tough, and building the mechanics and the electrical part of the stuff is actually not the hardest part to make work. It's getting the software stuff and processing data and it's
Yeah, again, like I said, everybody's doing a lot of the same stuff. How much of how do I talk to this, motor, this RG pilot, this Pixhawk, or whatever why does everybody have to learn, the protocol? Like it's not important. It's not what they want to be doing necessarily.
Right.
Yeah.
Right.
Okay.
Well, thank you so much. Thank you, Danielle, for joining us today. And we do these meetings every month, so feel free to jump in anytime if you just want to kind of hang out with us. That would be awesome. And if you get any new developments, reach out to me. That anything that you would want to share, maybe in a future presentation, just reach out to me. And
and again, anybody on the group that wants to maybe try it out and stuff, I'd love to work and do a little, help you do a project, and we can present it and show what you did.
Cool. Yeah, that would be awesome. All right. Well, thank you so much, and we'll appreciate your taking the time and putting this together to show us. And there'll be contact information and other things available for anybody that wants to reach you outside of the meeting. So.
I think, did you forward those slides in eventually?
Yes, Steve, I gave you a PDF file of the,
Wonderful. Thank you. Yeah. So, okay. So that'll be part of the post then, will be a PDF of this presentation. So anybody wanted to get any pieces of that. All right. Well, thank you so much. And we're just past the top of the hour. Well, yeah, I guess the top of the hour for you guys. It's already 1:15, and I'm getting really hungry because it's like way past my lunchtime.
Me too.
But I smell that lunch just arrived. I could see the pizza kind of floating behind me back there. So it's like, okay, I'm ready. I'm ready.
I agree with him.
Yeah.
Where's the robot that brings you the pizza?
Yeah, yeah. Well, they do have these robots that make the pizzas. I think I showed a video of that. There's some place, I think it's in Japan somewhere, they have this machine that, puts the cheese on, it squirts the sauce on and the cheese and adds things and stuff. And it's all completely automated. I mean, it's just, the raw ingredients go in one side and cooked pizzas come out the other side. It's pretty amazing.
Wow. It sounds like a
All
terrible.
right, guys. Another great meeting. Thanks for the presentation. See you.
Yeah.
See you all around.
All right. Yes. Okay. Same to you. Yes. Good weekend, everybody. Thank you. And I will be wrapping things up.